So quadratic equations, this is just the beginning part of it, completing the square. We'll get into the completing the square stuff. It doesn't have to make sense now, but a quadratic equation is a trinomial. So stuff that we've been seeing already in this x squared plus x plus something else. Usually we see it like ax squared plus bx plus c kind of business right there. This is a quadratic. And usually if these were equations, we'd say I want to make it equal to 0, right? But in the past, they've been very generous because most all of these trinomials could have been factored, right? But now we're going to start seeing them not being able to be factored, which is what brings up a quadratic equation. So to start this out, we're going to start seeing problems where we're going to solve equations, but we're going to use principles of equality. Now, I'm not so concerned with addition, subtraction, multiplication, or division. It is important to remember, though, that we use addition and subtraction to make zeros, which we're going to do. It's just not our main focus today. And then we use multiplication and division. We use these to make ones. Specifically, we want to make coefficients ones. All right? But we've now seen that you can use other principles of equality with square roots and exponents of 2. Really, the main idea I want to get across here with principles of equality is whatever you do to one side, you are going to do, you're going to have to do to the other side. Because if you don't, then you've jacked things up pretty bad, and you're going to be off a little bit, at least. So if we end up with something to the power of 2 equals b, you can square root the stuff. All right? So you could say, look, I'm going to apply a principle of equality by square rooting both sides. And yeah, sometimes we may be looking at binomials or trinomials, right? It's just, if you ever square root a power of 2, you have to take both the positive and the negative of that square root. Okay, and this goes back to, it's something to the power of 2. So if you looked at something that was like, hey, look, a squared equals 25 like this, you'd say, well, I can square root both sides, and that'd be great because a would be 5, right? Well, 5 works because 5 times 5 is 25. But since we square rooted something that was being squared already, the negative will apply as well. Because negative 5 times negative 5 is still positive 25. So you got to look at both. In fact, kind of like we would see with not squares, but absolute values. So if I saw something like that, where I saw a squared equals, I'll do a different one like 36. If I had to take the square root of both of these, I like to split it up in two separate equations, where then you'd have a equals 6 and then a equals negative 6. Now, again, will it just always be 36? No, it could be something like minus x squared. So, something like this, and then you take the positive and negatives of those. It wouldn't be 6, though, so I changed it. I feel like I should change it back. That's better. Okay, but the principles of equality still apply. It's just now, and I've talked about this before, if you have a power of 2 in the problem, you should have 2 answers. Sometimes it's only, you have the same answer twice, but we should expect to start seeing 2 answers for the most part. Now, like we've seen, though, with exponents, square roots as well, you need to check your answers. Because if it's outside the domain, which it shouldn't be, but if it were to be outside the domain, then you can't use it. Okay, so always go back to the original equation and check the 2 answers that you get. Okay, so on this one, all right, this is an equation. It's not really quadratic. We don't want to change it to a quadratic because I can solve this because I have something to the power of 2 equals something else, right? Like we saw, a squared equals b. So I can square root both of these, right? And then the square root of the power of 2 just leaves me with what's inside there, h minus 3. And then this would equal the square root of 21. But I guess I should at this point. This is where I would split this up. Okay, so I have h minus 3 for both. But they're going to equal not just the square root of 21, but also the negative square root of 21. Okay, because we're expecting to see 2 answers now. So if I were to solve these, I would actually solve them the same way. I'd say for both of them, Just going to add 3 to both sides. Right, that's going to zero out our minus 3's. That leaves me with just h equals on both. Now, these are not like terms that I can combine. I mean, there are constants, but the square root of 21, I'm going to treat that like a separate term. So this is going to be 3 plus the square root of 21. And then this one over here is going to be 3 minus the square root of 21. Now, I'm not going to do this. I'm not going to necessarily perform the check. I still recommend that you do. But the original equation was h minus 3, I'm giving myself space there, squared, equals the square root of 21. And if you were to replace that h with either one of the ones that we just found, 3 plus the square root of 21 like this, and you put that in the calculator, I'm sorry, it's not the square root of 21, it's just 21. If you put this into the calculator, you will get 21. And it would be true also if you put negative or minus right there, okay? So both of these are solutions. Let me specify that. So I put in the question mark over here. We found it's true because it would give us 21 equals 21. And again, this would be true also if you made a 3 minus the square root of 21, minus 3. Now, everyone knows 3 minus 3 is 0, so that zeroes out. So you'd have the negative square root of 21 to the power of 2, which is 21. Well, even if it's positive as well. All right, this one, again, is just another equation. But we have to solve for the x squared, meaning we got to isolate it first. Okay, so principle of equality here. I'm going to get rid of the 840, kind of like you just would with a regular x. So I'm going to add 840. So that zeroes out. I can drop my 45x squared, which equals now 845. And then I'll divide both sides by 45. And that'll make the coefficient of phantom 1. Now, I believe I get a fractional number out of this. 845 divided by 45. I don't want the decimal. 18.7 repeating. I'm going to push the double arrow button above it because I'd prefer to see the fraction. That decimal is pretty ugly. So I got 169 ninths on that. Okay, so from here, and there's another reason for that, but remember I'm going to square root both sides. Okay, so that means I'm going to split this up so that x then would equal the positive square root of 169 ninths, but x should also equal the negative square root of 169 ninths. Okay, and so the fraction, here's why the fraction is useful, is because the square root of these, right, 169 and 9 are both perfect squares. Now, if you didn't know that, your calculator did. So this ends up being 13 thirds positive, and then over here is just x is still, but it's now a negative 13 thirds. Now I'm not gonna do the work here, but if you replace x here with 13 thirds, positive or negative, you do get true statements out of here. 45, you'd end up with 45 times the 169 ninths, and then I believe that equals, yeah, 845. 845 minus 840 is 5. So they both check off. They're both true. Oh, crap. There we go. Both of these work. So all of this is actually meant to get us to completing the square so that we can start solving some of these equations. Solving a quadratic equation in x by completing the square. So you got to divide both sides by the equation by the coefficient of x squared. Yeah, because we really just want it to be phantom 1x squared. We don't want a coefficient with x squared. Then you isolate all the variable terms on one side of the equation, which means we don't want any constants on the same side. So we complete the square of the resulting binomial by adding the square of half of the coefficient of x to both sides of the equation. Now that doesn't have to make sense, which it probably doesn't, but it's this. You need to remember here that it says you're adding the square, so that would be a power of 2 of half the coefficient of x, not x squared. Okay, so I'm gonna be a math nerd here, which I always am, but that's ax squared plus bx, and it should equal some value over here, some number. You could put c if you want. Okay, but the middle coefficient is the term we refer to as b. Am I doing b better? That's okay. Okay, so you're going to take b. It said half of that coefficient, so you're going to have to divide that by 2. But you're squaring that. Okay, now this is something that you're adding. This is a constant, by the way. I did not put the x in with that term that I'm squaring. But that's what you add. That is what ends up being added. This stuff right here. That ends up being added here. But remember, that I kind of arbitrarily put that there. So if you do it to one side, you'd have to do it to the other side as well. So you'd have to, okay, well, I added it here, so I'm going to have to add it there as well. Now, once you get that, because you've done this, you've taken b divided by 2 and squared it, then it automatically will become a perfect square trinomial. That's why it's called completing the square, which means that whatever this b over 2 is, this part right here ends up just being, well, the a is 1, by the way, but it ends up being a perfect square trinomial, meaning you'd have x, and then I guess it'd be plus or minus, but whatever b over 2 is. And then it equals whatever you have on the other side, which you can just put into a calculator. I know this probably isn't making a ton of sense right now. Hopefully example will, but you factor the resulting perfect square trinomial and write it as a square of a binomial. Again, this should be a perfect square trinomial. Use the square root property to solve. Because once I get this squared, then I can square root both sides. I get my 2 answers, and then I feel so good. So by completing the square of the expression, find a and b. So I'm showing it right here like this. On the assignment, they actually may show it like this. So I'm going to show it both ways. Okay, so sometimes they want to know what's being added. Yeah. This one is taking this expression and then changing it into a new expression. But I'm going to take the expression and change it into an equation instead. I'm going to do both. So let's ignore that first one for now. So I'm going to erase it so it's just out of sight, out of mind. Let's just focus on this first one. Okay. So so this one's great because the coefficient of x squared, it's already a phantom 1. That's very generous. But what I'm going to do is I'm going to take my x squared plus 10x, and I'm going to purposely offset my plus 24 because 24, like if you tried to factor, oh crap. Well, if you tried to factor 24, you could use 6 and 4 there, and then make that a factored trinomial. But it's not a perfect square trinomial. That's what we got to do with these completing the square business, okay? So that's not what we want. Again, you could factor that out if it said, hey, please just factor it, but it says complete the square. So I'm offsetting the 24. Now, in order to figure out what goes here, it will also affect what I'm going to have to do to the 24. Okay, now that, again, it may not make a lot of sense right now, but really all I'm focused on right now is these 3 terms in order to force a trinomial that is a perfect square trinomial. Well, how do you do that? You're going to take the 10, the middle coefficient, which is 10. You're going to divide it by 2, and then you're going to square it. Okay, now I'm going to operate here. I know 10 divided by 2 is 5, so I can square that. 5 squared is 25. So if I were to take that x squared plus 10x, and let's say I added 25 to it, then these 3 terms, these 3 are now a perfect square trinomial. But I can't just add 25. It's not an equation. So really what I'm going to do is add 0, but I've already added 25. So how do I make that 0? Minus 25. Okay, so I didn't change the equation by just saying I'm going to add 25 and then I can sing and dance. I gotta make sure I balance that out by also taking away 25 from both parts of this equation, right? Because I've got the trinomial and then I'm dealing with just the constants as well. Yeah, so right, it doesn't look like we need this stuff, but once we start seeing equations, then we're gonna need this stuff. Yeah, I guess kind of. So this guess I should have given myself more space. But the 25, right? So I can say, all right, my 25 right there. 5 plus 5 is 10, so that would then be x plus 5. I'm not going to do it twice. I'm just going to show a power of 2. And then over here, I've got 24 minus 25, which would be negative 1. And so the way they have it up there, right, they're saying, well, x plus a squared plus b. Right here, I can see that the a is 5, and then the b is negative 1. Okay, now that's this format. If they give you this format, this is your a and b. Like I said, they may change the format.
Where did you get the negative 1?
So how does that change? Well, the expression right now that we have, we're showing is x plus 5 squared. And we had it as minus 1. So really we would just say, look, make this equal to 0. And then to solve that, you would just add 1 to both sides. Okay, that zeroes that out. Then you get 1 equals the x plus 5 squared. And the format, like I was saying, is that x plus a squared equals b. So in this scenario, a still equals 5, but now the b is a positive 1. So I'm showing both formats because I can't guarantee which one they're going to do. Like I said, I think it's usually going to be this one. So I'm going to box this one in. But again, this format, these two can still work depending on which one it asks for. Now, here's the thing is, the way that we explained this process is usually you would take this constant 24 and then move it to the other side of the equal sign. Now, if this equals 0, you'd end up with negative 24 over here. So if you added 25 to one side, you can balance that out by simply adding 25 to both sides if it were an equation. But this one was an expression, so I was forced to make it a 0 by adding 25 and taking away 25. So here we go. So this one now, it is an equation. It says to solve it. All right, that's good. Now I'm going to complete the square on this one. And if you tried to factor out 31 here and say, or even if you tried to add 83, 31 plus 83 is 114. There's no two factors of 114 that will add up to negative 16. So that's no good. So here's what I'm going to do. I want first to get the x's on their own side of the equal sign, meaning not just the x squared, but also the negative 16x. This also tells us that I don't want, right now, the 31 on the same side. Okay, now if I'm solving an equation, I'm going to put my constants on the other side of the equal sign. And there's a reason for that.
So we're not going to do it.
So, yeah, the 31 there, I'm going to zero it out by taking 31 away, so minus 31 from both sides. That does zero that out. That's very nice. But negative 83 minus 31 is negative 114. Now I am ready to complete the square. And again, we're looking at this it's binomial, but I'm going to force it to become a trinomial. Okay, so what value am I going to add to that? Well, I'm going to take the middle coefficient, and I would actually call that middle coefficient negative 16. Remember, we're going to divide it by 2, and then that value we're going to square. So then that would be, thank you, negative 16 divided by 2 is not negative 4. It's or whatever the crap I put. It's negative 8, and then negative 8 to the power of 2, thank you, is 64. Now, over here in the equation, remember, whatever you do to one side, you have to do to the other side. So where I'm completing that square by adding 64 here, I need to make sure I do it to the other side as well. Okay, so now, because it's an equation, whatever I do to one side, I got to do to the other side. It's not an expression where I'm trying to zero out this 64 on the same side, where if it were an expression. If I add 64 here, I can just simply add 64 there, and I can call that good. Now this trinomial, because we used the perfect square process here, is going to be a perfect, it's perfect square trinomial. It is a perfect square trinomial. So the 64, what two factors of 64 add up to negative 16? Yeah, it's the negative 8. Well, didn't we see that before? Yeah, we did. Remember the negative 8 over here? It's the same one. Now, instead of writing this as two binomials, I'm still going to write it as two binomials, but as a square, because that's what it is. So it'd be x minus 8, that to the power of 2. Maybe I shouldn't have written that so big. But then I've got the negative 114 plus 60, which is, plus 64. Yeah, negative 50. So this takes us back a couple slides, where now I'm going to square root both sides because it's it's a square, right? So if I square root both sides, and it doesn't matter now that that's a negative 50 because we have complex numbers. But now I just end up with, remember, I'm square rooting both sides, so I'm going to split this up into two equations. So I got x minus 8. It could be the positive square root. Well, I'm just going to put I and then 50 right here. So I skipped a little bit of a step there. But if x minus 8, if we could get that to equal the negative I square root of 50, that's fine too. So to finish this off, principle of equality for both, and it's the same thing for both. I'm just going to add 8 to both sides. I would consider these not like terms that I can combine. So I end up with x. It could be 8 and then a positive I square root of 50. Or x, it could be, because we zeroed these out, 8 minus I times the square root of 50. Put an or statement there. Both of these are good. Yeah. I forgot to mention, because I forgot here, always simplify your roots if you can. And the square root of 50 can be. Now, I'm just recommending you just plug that into the calculator and be done with it. All right. So you'd have 8 plus, it'd be 5. I root 25, that'd be 2. And then also 8 minus 5i root 2. Okay, because 50, I'll do this by hand, but that'd be 25 times 2. And the square root of 25 is where that 5 comes from. But it would work for both of these. Again, yeah, I hope it's not, but again, to simplify this, especially if you're looking to save time like I'm trying to do right here, just put this in the calculator, square root of 50. So again, this one, extraordinarily generous. There's no coefficient of t squared, which if there was, then we would have to divide all the terms by that. And yeah, you can end up with fractions sometimes. But right here, what I would like is to isolate the t squared and t, all my t terms. So I would like this to just end up being t squared minus 6t. And I do not want, not 60, but 6t. Sorry about that. The negative 47, I got to zero that out. So add 47 to both sides. Okay, so it's going to equal 63. Yeah, that was good. Now, why did we do that? It's because I'm looking to complete the square of these two terms. Again, that's a perfect, it's going to be a perfect square trinomial. So it's t squared minus 6t. And I got to have a value right there. Now, since it's an equation, again, since it's an equation, it is a principle of equality. If you do something to one side, you must do it to the other side. So I'm going to take my middle coefficient there, which is negative 6. I'm going to divide that by 2, and I'm going to square it. Okay, so just by working with the order of operations, negative 6 divided by 2 would be negative 3. I think I did that right this time. And then negative 3 to the power of 2, negative 3 times negative 3 would be positive 9. Okay, now that 9, I'm going to add it to the t squared minus 6t because that completes the square. It makes these three terms a perfect square trinomial, but it's an equation, so if I do it to one side, I need to make sure to do it to the other side. Okay, now I know that 63 plus 9 is 72. That's not bad. But my perfect square trinomial over here, the 9, right? What two values of 9, factors of 9 add up to negative 6? It'd be negative 3 and negative 3. It's the same value, so I'm just going to write it as a square binomial. So that'd be t, but those are negative 3's there. Okay, so this is my new equation. Now I will square root both sides, but since I'm square rooting a square, I'm going to split this up into two separate equations. So now I've got t minus 3 should equal the square root of 72. I'm not going to make the same mistake last time. I'm going to put this in the calculator so I know if it can be simplified, which it can. So but also t minus 3, if I could get this to equal the negative square root of 72, that'd be good as well. Okay, but this becomes an equation that we just need to solve here at the end. So we'll add 3. I'll simplify it still, but I'm going to wait till the end. So now we've just zeroed out those negative 3. So we'd end up with t equals, I've got 3 plus the square root of 72 there. But also on the other one, I got t equals 3, but now minus the square root of 72. So 72, one of the factors is 36. So the square root of 36 is 6. Should be 6 times the square root of 2. But I'm going to put this in the calculator just to make sure I don't make any mistakes, or hopefully. So I get both answers now. So I got t, I could have it be plus, square root of 72 is 6 times the square root of 2, or, so I got my comma there, you could have 3 minus 6 times the square root of 2. Now this one, it doesn't have any I values in it. So if you were wanting to try this, you could plug this in or just use the store function of the calculator and then just type in your equation. You will get 2 true statements. 3 plus 6 times the square root of 2 squared minus 6 times that minus 47 is going to be 16. Same with this other one.
Wait.
All right, this one, they did give us a coefficient of x. So if I'm going to use completing the square garbage, then I got to get rid of that 2. Now, whether you get rid of the 2 now or later is up to you. I'm going to wait because I don't want to deal with the fractions, meaning the 5. I don't want that 5 there, right? So I'm going to zero that out by subtracting 5 from both sides. And that zeroes that out as planned. And now I've got 2x squared minus 8x equals negative 5. And yeah, remember, I'm keeping this space here because I want to complete the square and make that a perfect square trinomial. And I will pretend to enjoy to do it. But my coefficient is a 2. So remember, if I'm going to make that a phantom 1, which I will, I need to divide all the terms by 2. Now that's going to give us a fraction on the right. That's not bad because the calculator is going to do that work for me anyways. But I got phantom 1, x squared, minus 8 divided by 2 is 4 x's. And this now equals negative 5 halves. Now if you want to change that to negative 2.5, that's fine. I'm going to keep it as a fraction though, because I think it's pretty. Now I will complete the square. So I'm going to take my middle coefficient there, the negative 4, and I'm going to divide it by 2 and then square that. Okay, so negative 4 divided by 2, that would give me negative 2. And negative 2 to the power of 2 is 4. Okay, so that means that I would add 4 to complete this as a perfect square trinomial, but if I do it to one side of the equal sign, I must do it to the other side. Plus 4 plus 4. Now, I will factor the negative 4, so that'd be the 2 factors of negative 4 that add up to negative 4 are negative 2 and negative 2. So that gives me, again, that's a perfect square trinomial. That's the whole point, but it's x minus 2 squared. And this equals, again, I'm just going to put this in the calculator. So negative 5 halves plus 4, enter, and it says, oh, it's 3 halves. Next up, just like we've done before, I'm going to take these and then square root them, right? So that I can just get the equation. But I'm square rooting a square, so I got to change this into 2 separate equations. So I got x minus 2 would equal the square root of 3 halves. But also, if I could get x minus 2 to equal the negative square root of 3 halves, that'd be good. And then, yeah, we got this equation to solve, and we're going to pretend like we enjoy it. So there's plus 2 on both sides for both. Again, that's to zero out your minus 2's there. So then we get x equals, it'd be 2, and then plus a square root of 3 halves. But also, x could equal 2 minus the square root of 3 halves. Now, this is not actually complete, because we cannot have square roots of denominators. And right now, this is the square root of 2 in that denominator. So, with a little bit more space, let's do some work on these. All right, now I'm going to work on one, and then I'll work on the other. So I'm going to change this. It's still going to be 2 plus, but now I'm going to change it into 2 separate square roots. So square root of 3 over the square root of 2. I need to rationalize that denominator by multiplying it by the square root of 2. Okay, because square root of 2 times square root of 2 is 2. So now I've got 2 plus, and then up here it's the square root of 3 times 2. Sorry, the square root of 3 times the square root of 2, which is the square root of 6. Now it is rationalized. So that's my new x right there. It's the same x, it's just without the square root of 2 in the denominator. So I'm going to do the same thing to the other one, though. Okay, but it's just minus, so it's 2 minus but I've got this, it is just, I'm doing it twice just because I'm having so much fun doing it. Because I'm a math nerd. So, yeah, it's still 2 minus, and then the denominator is still, well, it's still 2. Square root of 2 times the square root of 2 is 2, and then the square root of 3 times the square root of 2 is still square root of 6. So this is my 2 answers. Just so you understand, usually if you're writing this by hand, if you get deep enough into the math, they'll just write it like this: 2 plus or minus the square root of 6 over 2. It's showing both answers just in a different way, but I'm going to keep the way that we had it there. This stuff.